Hello students, welcome to our classes, and today I am solving Isi Mmath Subjective 2018 paper. This is the second video. Question number 2 we will be doing. This is a real analysis problem. They've given f of 0, 1 be a real valued continuous function which is differentiable on 0 to 1 and satisfied this condition. And suppose there exists a constant c, and in this range show that fx equal to 0 for all x. Okay, so if we denote m equal to maximum of x belongs to 0 comma 1 mod of fx. So for any x within this interval we have what we have, mod x. So mod of fx minus f0, that is equal to, in the same interval, 0 to x f dash y dy. Now that is also according to the structure 0 to x f of y dy less than equal to cxm less than equal to cm. Okay, so since the estimate holds for any x, so for any x which is from 0 to 1 the estimate is holding, so we can say that the max in x, so we can get it m cn, so 1 minus c whole into m, this is also less than equal to 0 from this. So the assumption 0 less c less 1 implies 0 less than equal to m less than equal to 0, so that is m equal to 0 and fx is also equal to 0. So for all x 0 to 1, so this is true. So the next one is a group theory problem. G is given as an abelian group, order is given as n, and f of g comma c is a function. Then prove that for all h belongs to g. So this is true. So this is very easy. So for h belongs to g, so mapping of g of hg is a bijection. Okay, of g. So when g ranges through g, so the product hg also ranges through g. So now we can write it as summation of f of hg equal to summation of f of g. So where g belongs to capital G, and here also in the limit g belongs to capital G. So hence directly that's the answer. So now it has a second part. We will go to the second part, 3b. 3b says let C star is the multiplicative group of the non-zero complex numbers, and this is a homomorphism, so we need to prove this. So h belongs to g we know, so f of h summation of f of g is f of hg, that is equal to summation of fg. This is true. So now taking h belongs to g, we get fh fg in summation of f of g. So obviously these two will be multiplied, so f of g, as these two are same, n of f of g. So for these two parts we can just replace h to g. So now we are taking a square. Now we can take fg common. If we take this part here, so n minus summation of n minus, or if we just take this part here, so n minus summation of fg, and that is equal to 0. So either this is equal to 0 or this is equal to 0. So obviously this or this, so summation of fg equal to 0, so this is true, or this. So finally proved. Now going to the third part. So in this third part they have said that f of g to c is an homomorphism, then prove this. So in this case the identity h of f of hg mod is f of h and f of g So f of h mod f of g. So this implies that g is actually going for f of g. So this is also a homomorphism. So by the previous part, either of this part, so g to g, f of g, this part equal to 0, or g f of g equal to n. So here we have this part is not equal to 0 anyway. If g is not equal to 0 as g belongs to g, so obviously mod of f of g, this thing is greater than 0 and this value is greater than 0, which follows directly this value. So all the parts are proved.